And I got a full-time job, man.
What I would do is drop in during office hours, explain the situation with what you got going on, see if there's something that can be worked out.
Yeah, she's pretty, um, she's pretty cool, but still, I mean, just the amount of free time that I have compared to, you know what I mean?
Yeah, I do. Yeah.
That's the issue.
Well,
Cool.
standard advice too, just for any class, if you're taking a lot of classes at ISU, is you always have lots of rights as a student. You can always talk to the professor. And if you know there's something that's not going right in class, like common things that can be problems is never getting homework returned like ever, and then having a final exam, that's a bad situation. You could talk to the professor. If you don't like the answer for the professor, you can go to the department chair of the entire department and talk to them about the problem. And if you don't like the answer from there, you can escalate it to the provost, to the dean of students. If you know something just isn't going right in your class or this class or any class whatsoever, you can always escalate things. And they never really tell you about that as a student, but that's a lot of rights you have as an ISU student. And you'll know in your heart if something is just not right, if something's kind of off about a class and it's costing you a grade or something like that. But welcome back, folks. I don't have any notes on here because I forgot the recording going. And it looks like it is just us three today, but hopefully some others will make it in. Today, we're going to start off just by taking in questions on the exam 3 review. Then if we just run out of steam on the questions, we might go back to section 15.1 and push forward there. But I'm happy to spend as much time as we'd like going through those exam 3 questions. So just as a quick rundown, our quiz number 9 is due today, and I forgot I do have those graded early for those who turned them in early. Here's this back for you.
Thanks.
You bet. If you haven't submitted it yet, then try to get that done as soon as possible because the quiz number 9 is based off the last problem on exam 3, the chapter 13 conference interval problem. Even if you get it to me sometime on, say, Saturday, even evening on Sunday, I'll be able to on Monday morning get it graded and sent back to you so you can get your feedback on that. So the coverage is just these 3 chapters. There'll be one problem in chapter 7. This is going to be doing a regression analysis problem, similar to what we did on, I believe that was quiz. Let's see here, 7. Chapter 10 is about, once again, thinking about the population versus the sample, statistic versus parameter, and observational study versus an experimental design. So similar to the quiz 8. And I have 2 questions I'm going to ask in chapter 13. One of the questions is going to be about condition checking on the central limit theorem. I'll only ask 3 direct parts. There might be another additional question on what's the parameter, those kinds of things. And the final question on there, like we mentioned, is basically the quiz 9, just a different problem on doing a conference interval. So we're not going to involve chapter 14 on the conference interval, the chapter we just completed yesterday. It'll only go up to that chapter 13. And standard advice, make sure you have, probably as a very first thing to do after completing the quiz, your notes put together so that when you go to study these things, you have your notes available with you. You're actually using your notes. If you wrote them down and it's the best notes in the world, but you haven't actually used them to orient yourself on them, they become kind of overwhelming on exam, probably causing more harm than good in some cases. But that's just my standard advice for exams. It's going to be kind of like the experience on exam 1 and exam 2, where if you're prepared because you did all the quizzes, you're caught up on the MyLab statistics homework, then you'll have a really good idea what's coming on up on the exam. These 2 sample exams, version 1, version 2, also give you a great idea of what questions are going to look like, the kinds of things you'll be asked. They're pretty long, so keep in mind I can't ask all the questions. It's just going to be the 4 problems we discussed. Version 1 is brand new problems. This looks like a brand new problem, question 30. And version 2 is just the ordinary lecture notes where all the formulas and other noise have been pulled out. There's solutions to this one on the Canvas webpage. And version 1 has solutions at the very bottom. But if you see anything that seems off on those solutions, let me know and I can get them corrected right away. Well, other last bit of advice, don't forget your calculator. I'll have spares if anything goes wrong with yours, but it's always comforting to have the one you know and you like. Because my calculators I hand out are like this one right here. If yours is a little bit more fancy, if you can control the left area, middle area, right tail area, you might not like being given one just like this. Well, any last questions at all, folks, before we get started with the review? Okay, well, it's a short class today, so really it's all up to us. Any questions, folks, would like to start off with to begin? Or I could pick one. How about that? I'll pick one to start us out, and then I'll turn it over to you folks on where to go from there.
Perfect.
So
I forgot my remarkable stroke.
one I'd probably pick would be probably new problems, because even though we've probably don't have a verbatim memory on exactly how these go, sometimes you get a little bit better practice if you're looking into actual new stuff. So I'll go to version 1. I have a couple, well, exactly one problem on chapter 7, so let's copy this in. On this file here that we're building, I'll post the solutions to this, everything we do, right in, probably right here, above version 1, version 2, between the exam 3 information. It's just going to be titled exam 3 class review. Let me change the layout so we can get more visual space on this. Okay, so going through this problem number 30, you'll have plenty of time to read the context, and sometimes that's a good first thing to do. It says, in the study of the tufted titmouse, Parus bicolor, an ecologist captured 7 male birds, measured their wing lengths and other characteristics, then marked and released them. We're told next, during the ensuing winter, he repeatedly observed the marked birds as they foraged for insects, seeds on tree branches, noted the branch diameter on each occasion, and calculated from 50 observations, average branch diameter for each bird. You know, actually, this feels familiar. I think we did do this one.
Yeah.
Sorry, these were meant to be new problems, but I think what happened was I threw in an additional extra example. I just plagiarized myself from the review question. So yeah, we have solved this one before. Sorry about that. This one is not as new of a problem as I thought it was going to be. Let's see, I don't think I have another source for new problems like this one. Should we move on to something different, or should we solve it just for the practice? I'll leave it up to you folks.
What do you wanna do? I feel pretty confident in whatever.
It's up to you, Christian. Sorry to put you on the spot.
Yeah, I mean, I didn't think that all, well,
You felt pretty good with this?
yeah.
Me too.
I really think,
Okay, let's go to a different first problem then.
This one, we're just putting it in the calculator, right? We're going to staff, we're throwing it in the L1, L2. And then we're using bars to option 8 to get the squares regression line. Pretty much is it.
Yeah, it sounds exact. So you'd go to the stat key, like you said, put in L1 for X, L2 for Y, hit stat key again, right arrow to calculate, and down to option 8, linear regression. You'll spit out the equation that we're looking for, least squares regression line, and then pretty much you're in business from everything else down below. So yeah, it's again not too bad of a problem. There's a similar one on the quiz problem, similar one in the lecture notes, and this one was the additional problem in the lecture notes. Should have reminded myself that I copied this one down. Sorry about that. Let's do a second version then of a first problem. So chapter 7, regression. Then chapter 10 is dealing with sample surveys. These questions are kind of broken down into small parts, like 33, 34 are just really fast questions on parameter versus statistic. 31, 32 are a little bit longer, a population sample, whether it's a study or experiment. I would say these are pretty good ones right here to take a look into. Let's give these a try for a good roundup of chapter 10. Only thing that's not captured in both those highlighted problems is parameter versus statistic problem. So this is actually new information, so that's kind of helpful. Hopefully, let me know if some of this seems familiar. 31 says some companies offer a 401k retirement plan to employees, permitting them to shift part of their before tax salaries into investments such as mutual funds. Employers typically match 50% of employees' contribution up to about 6% of salary. And one company, concerned with what it believed was a low employee participation rate in its 401k, sampled 30 other companies with similar plans and asked for their 401k participation rates. So based on that information, looks like financial data, we want to know what is the population, what is the sample. And the order of the questions is not always the easiest way to answer it. That seems like a dead giveaway, right? The fact it said they sampled 30 other companies with similar plans. I'd say describing the sample is the fastest one to do on this. And you can be pretty brief when you describe the sample, as long as you fill out the information on what the population is. So for the sample, we'll say the 30 companies selected. And just as a reminder, let's put this in the instructions. Often these questions will say, use the context. Let's throw that in just as a fast reminder. So if that's the sample, 30 companies selected, we can be more descriptive on the population, getting all the context down. And we might start by saying all companies, but it's not exactly all companies, right? We're not including literally every company. We have to be more specific on the population.
All companies who offer 401k.
I would agree with that. So they had to, this is all about 401ks in the first place, right? So let's say all companies that offer 401k, I'll just abbreviate that to plans with understanding we're talking about a retirement plan. All companies that offer 401k plans. I think that's pretty good. I don't think I would take off points for something like this on an exam. And then with these kind of problems, you could debate yourself and each other kind of endlessly. You can be really hyper specific. Is there anything else you can see that you might add?
I don't know, this is where I always talk myself out of points, right?
It's easy to do sometimes and kind of go in the wrong direction. You know, for these kind of problems, if you said something that wasn't quite right on this, I probably would just cross it through and focus on that part. So I don't think this is one we could accidentally bury ourselves on. And honestly, to me, this looks pretty great. They did say somewhere employers typically match 50% of employees' contribution up to 6%. I don't think that's anything we'd include. But one company concerned with what it believed was low participation rates sampled 30 other companies with similar plans. So if we were trying to be even more specific, we would say all companies that offer 401k plans similar to this company. What's this company? It's the one company that decided to do the study in the very first place. They only want to look into people that are like them, maybe same size, maybe they're both on the stock market, or both are maybe nonprofit companies, something along those lines. They want to just make sure they're similar as possible. So if you want to be specific, there's not a lot going on there, but I feel like that's the one thing that tells you it's not just everybody offering a 401k plan. They also have to have some similar features to this company that started the study in the first place. Well, that's the setup so far. At this point, what would you say for the overall part C? Would this be observational or would this be an experiment?
Observation.
Yeah, absolutely. We could say right away, this is and observational study. I think the explanation is sometimes kind of tricky on this, but if you focus on what is an experiment, usually that's the best way to narrow this down. An experiment is really specific in that you had to take the 30 companies in the sample and then split them into 2 or more treatments. Well, what would the treatments be on this? It doesn't make sense. We're just looking at people with 401k retirement plans. There's nothing along the lines of give this first batch of 15 companies randomly pulled from the sample one experimental condition, the other 15 another one. That doesn't even really seem to make sense in this problem. So you can say it's an observational because it's not an experiment, but then we can say more specifically the full explanation. It's an observational study because there was no experimenter that randomly assigned the 30 companies. You can say to more than one experimental condition, or you can just abbreviate it to say that randomly assigned the 30 companies to more than one treatment group. Just as a differing way to say that. In place of treatment group, you could say experimental condition. And I think these are pretty tricky problems because if we're thinking on the quiz problem, the one that was by a weird herbal supplement, forget what it was exactly, it almost felt like that was an experiment, but all the participants took the supplement. The only thing that actually makes it an experiment is if there was, say, half of them that randomly took the supplement, then did the memory test, and then the other half took something that was a placebo, just a sugar pill designed to look like the supplement, and then they took the memory test as well. So I think that would have been quiz number 8. But any other questions on this one, folks? Okay, let's try it out all over again. So new scenario, new context. It starts off with a statement I think a lot of people would probably agree with. Cocaine addiction is hard to break. Addicts need cocaine to feel any pleasure, so perhaps giving them an antidepressant drug will help. So that's a kind of a weird cold start to the context. It says one study randomly assigned 42 chronic cocaine users to take either an antidepressant drug, diazepam, lithium, that's an antipsychotic drug if I remember correctly on that, or a placebo. Lithium is a standard drug to treat cocaine addiction. I didn't actually know that. I guess I forgot after reading this again. So there's 3 groups altogether on this. Would you agree if we jump to part C, that automatically says it's an experimental design?
Yeah.
I would too. If they said this though, this is where you might have a problem with that. If the study assigned 72 chronic cocaine users to take either one of those treatments, that would be a big problem. For example, there can't just be a sign-up sheet. Which treatment do you want? Do you want the antidepressant? This is our study. Do you want lithium, the typical thing, or the placebo? You can't allow people to do that because if these people know what treatment they're going to be put into, it's going to affect the outcome of the study, how they're actually behave when they try to get recovery on this drug. So the fact that they're randomly assigned and they probably don't even know what treatment they're in the first place is what allows us to be a true experimental design. So let's jump to that part in view of what we did in part C. This one is an experiment since
there is an experimenter.
yeah, since
Subjects.
assigning subjects
could you say?
Do,
Assigning subjects to the conditions of. That'd be over it.
Yeah, so we could say the conditions of, we'd have to be referring to those three things right there.
Just of the different, of the three different treatments.
Yeah, that'd be a great way to say it. You could list this all out, but that's a lot of writing, right? So just saying the three different treatments is a great way to save some of your time on the exam. Three different treatments.
Period. Done.
I would say that that would be a period on this one. If it was missing the random assignment here, that would be a problem with the experiment not working correctly. But this is the main key. For it to qualify as an experiment at all, you have to be splitting the subjects into the different groups. So if you want to add more, you might say by random selection. But I would say that this would be a full credit kind of response on this one.
You could add randomly after experimenter.
Yeah, you could
Randomly
say
assigning subjects.
there's experimenter. Yeah, that'd be a great place to put it, randomly. Or you could tack it on over here and say by random as well at the very end. We got it. That's the essence of what's a true experimental design on this one. That means, what were they trying to measure on this? Probably the outcome on how they dealt with the addiction. So depending on what those outcomes look like, if this drug had better outcomes altogether, they could say the drug itself caused those better outcomes. They would have to do statistics like we're doing, confidence intervals, other kind of fancy kind of tests as well. Well, we've got the experiment down. Sample would just be these folks, right? We could say the 72 subjects generically. We could say the 72 chronic cocaine users if we want to be more specific. Let's go with that route. The 72 chronic cocaine users. So they'll have to have a definition of what that even means in the very first place. But then the sample comes from the population. So you would say here, all chronic cocaine users. And it's good to reread the context one more time after you go through this kind of stuff, just to make sure we didn't miss anything or maybe misinterpreted something. Anything you can see that you might add to any one of these parts, particularly the population, is a good one where it's hard to get everything in.
All cocaine users who are depressed. I don't know. I feel pretty good about that.
Yeah, I'd say this is a good one to leave just as is. All we know is that they're chronic cocaine users. We don't even know if they're depressed. Some of them might be having just a perfectly normal life, they think, and everything is just fine. It's weird that they did give them an antidepressant drug. That was the new thing about the study. Maybe just to see if it'll do something random like lithium. I didn't know lithium is for a standard drug for cocaine addiction. It's also used as a lot of different kind of contexts as in psychology as an antipsychotic as well, kind of a classic one. So this is already a pretty weird problem we're looking into.
On the second sentence is like, that's a pretty bold claim. Addicts need cocaine to feel any pleasure.
Yeah, that was a really strange thing to say at the very start. I don't know what the science is about that, probably something with dopamine, but to say to feel any pleasure, it almost feels like we're trying to dehumanize these people at that point.
It's not very.
Kind of a rough problem. Sorry, you say again?
It's not very person-centered.
Not at all, yeah. It feels judgmental the way it was written out on the very first place. So strange problem, stranger wording on this one. Other questions or observations on this? Thanks for pointing that out. I think I typed these problems verbatim for textbooks, so says a little bit of something about the textbook as well, the way that was written out. Okay, this is kind of the crux of what we're doing in chapter 7. You'll notice there was another thing that came up on the quiz that could potentially happen on this exam or even the final exam. So just remember, the moment you said that this is an observational study, if this part ever comes up, this implies we cannot make a cause and effect conclusion. No matter how tempting the problem looks like, it had to be an experimental design. So whatever happens here, maybe there's no effect in the data, and so they don't have a cause and effect conclusion. But if there was a real effect, if there's different outcomes amongst these 3 different groups, because it was an experiment here, we can, I'll just say potentially, make a cause and effect conclusion. Well, we did it, folks. We got through this problem here. At this point, this is kind of the main things we're going to be looking into chapter 10. Any less problems that you want to take a look into, we can look into the ones of statistics versus parameters, or move on to chapter 13. So up to you folks. We've got about 42 minutes at this point and some change.
Can we just kind of, maybe just do a quick, you cool with that? Like the first one, we went pretty quick through it, right?
Yeah, these are just 1 question problems. So yeah, let's give another one and take a look just to see how these go. This shouldn't get too far into our chapter 13 problems, and we can move into the next one later. So for the next one, thanks for taking the lead on this. This says on the December, that looks like an odd typo. December 8 to 9 Gallup poll. Maybe they're saying a poll conducted on more than 1 day. That's some really weird wording though. On the December 8-9, 2012 Gallup poll conducted yeah, this doesn't seem to be very grammatical. On December 9 to 11, 2012, Gallup poll conducted a telephone interview with a random sample of 1,069 adults, 18 years or older, living in all 50 states and the District of Columbia, and asked the following question. Well, in case it's relevant, we have a sample size, 1,069. Here's the question they asked. Would you like to see the government leadership? What would you like to see the government leadership do in the fiscal cliff negotiations? Sounds like this might have to do with government shutdowns looming, so that's in context with today. Stick to their principles and beliefs on tax increases and spending cuts, even if no agreement is reached by the January 1st deadline. Or, this is the questions everyone was asked verbatim on the street, so you can imagine if you're not really paying attention to the news that's going on and right away, this might be kind of a strange question. Or compromise on their principles and beliefs on tax increases and spending cuts in order to reach an agreement on the January 1st deadline. So Gallup Poll is a professional polling organization. They try to train all their pollsters to do these surveys by asking these questions verbatim in the same kind of way. Try not to give any indication that one response is preferable to another response to try to get as meaningful data as possible. Gallup poll reported that 70% of the Americans say leaders should compromise. Our job is to decide, would that be a parameter or a statistic that Gallup poll is referring to?
So a parameter describes the population, right?
Yeah,
And the statistic describes the sample.
exactly. Let's put that in the notes just to start this out. Describes the population. And the statistic describes the sample. This is an interesting question to kind of answer. When they say 70%, we have to decide, what is Gallup poll referring to? are they saying 70% of everybody? Or are they saying 70% of these people surveyed amongst all 50 states, District of Columbia? That's what's going to make or break this problem. And I think this is what is kind of hard to argue. So the explain could allow us to argue in both directions. And if your explanation makes sense on what a parameter statistic is, I would take it as a full credit on this one. Because that 70%, I think it's kind of up to argument. What do you all feel that Gallup poll's talking about? Do you feel like they're talking about the data? Or all, I think, some 350, 60 million Americans?
I think that they're probably talking about everybody.
They said literally here, 70% of Americans. You know what Gallup poll would also do is they would take the data and do a confidence interval. So they would say 70% of Americans plus or minus a particular margin of error. Margin of error would be small because they do large samples to keep this within a couple percent at worst. But yeah, if you went that route, you would have to say 70% is a parameter because here they're not saying the sample exactly, are they? It seems like they're talking about everybody when it's written out in this way because it is describing the population of all Americans. So I think that's a good way to answer this one. If it said something that said Gallup poll reported that 70% of the sample said leaders should compromise, that's going to flip it to they're definitely talking about these people right here. But when they go to give this in their report, they're estimating the parameter. That's what they're trying to say. They're involving everybody now when they say the Americans. That makes sense to folks on this one. I think this one was a pretty tricky one to look at. It all came down to how do we interpret this? If we decide that this is the population, and it looks like that's what they're saying, the population, then 70% is definitely meant to be a parameter. Doesn't mean Gallup poll knows that parameter exactly, but they're treating it as such. That's their estimate for this parameter. Well, that's chapter 10 in a nutshell. Before we run out of time, we should look into a couple chapter 13 questions, but any last questions or comments with this one? Okay, so let's move on to the next. So chapter 13 has split into two kinds of questions, and it's going to be the same on exam 3. First question is checking the conditions of the central limit theorem. That's why you're seeing randomization, 10%, success failure. Just like what we did in class, I'm skipping the independence condition because that just means you have to know just about every single thing about that study to really give a conclusion. Then the second kind of questions are going to look like these. Describe unknown parameter, construct the confidence interval, and then give a practical interpretation. Turns out I'm not going to ask these kind of questions here, the concept questions. I put them just here for the sake of completeness. So they're going to look a little bit more like these here. So going down the line, I'll leave it up to the class. Should we try one of the condition checking first?
Yeah. Knock them out.
Okay, so first is do's and don'ts for job seekers on social networking. And, oh, sorry, Abby, I just noticed that you made it into the class. I'm glad you made it today. And the second one is a National Health Organization warns 30% of middle school students have been drunk. I think we looked into these data already once before. So I think this is going to be definitely the new question from the notes.
Yeah.
Okay, putting this one down. Let's might as well put it on the new page here. So article, career experts, do's and don'ts for job seekers on social networking include raw data of 2,667 hiring managers and human resource professionals. So that's our sample size already. And I think so too. I think the only difference is we didn't have the actual numbers on it. We just launched into looking at sampling distributions based off this kind of context. These problems are not as new as I thought they were. Sorry about that, folks. I'm having some remembrances on this one as well, recollections. So we have data from 2,667 hiring managers, human resource professionals. The article noted that more employees are now using social networks to screen job applicants. I think the problem we looked at was more about friending his or her boss, is what that last one was like. But it might have been the same exact study, just we're looking at a different aspect of it. Article noted that more employees are now using social, no, actually, no, this does seem familiar. Of the 2,667 people who participated in the survey, 1,200 indicated they use social networking sites, such as these three, to research job applicants. Assume that the sample is representative of hiring managers and human resource professionals. So that's our data so far. It's categorical because we have a notion of what would be a success in this problem. We have a sample size of hiring managers, and of all those hiring managers in the study, 1,200 indicate they use social networking sites to research job applicants. Would you all agree that that would be what the success is in this problem?
Yeah.
Awesome. So it seems to be the thing that they're studying specifically. The one thing that they mentioned happened in the sample. It's the focus of the study, and that's what makes it the success. So in context, a success is I'll just abbreviate it to hiring manager, even though it includes human resource professionals. Hiring managers, or the hiring manager, used social networks or social network sites. We don't have to mention the three, but this was just examples of such sites to research job applicants. So that's what we know about the problem so far. Next thing we'll check is the randomization condition for the central limit theorem. They never said anywhere how they got the survey of 2,667 hiring managers. It's nice that the sample is representative of hiring managers and human resource professionals, but let's check those central limit theorem's conditions specifically. In section 13.1,
That's the three of the three things, right?
yeah, exactly. I think this was it 13.1 or 13.2? I'm starting to get a little vague on that. I think it might have been 13.2 actually. So in 13.2, once I get these windows to the right size, here's the central limit theorem we're looking into. The assumptions and conditions are these three right here that we're checking. But with the way the central limit theorem conditions were listed out, it said the data must be generated from some simple random sample. So this was the main thing written into that condition. It's nice that it's representative, but if we're checking the central limit theorem verbatim, we don't have a simple random sample. At least we were never told we have one. They kind of admitted that they didn't when they said the sample was just representative. So I would say on this problem, the condition does not appear to be met because the sample is stated to be representative, but not random. And the central limit theorem wanted something even more specific. It wanted the simple random sample. where every sample size of size 2,667 had an equally likely chance of occurring. So this one was a very highly specific condition, the simple random sample. So if we're looking into the central limit theorem conditions directly, appears it's not met by what they told us here, just a representative sample. Other questions with that condition there? Okay, well, we can check the other conditions. The 10% condition is where we had the most discussion and questions about in class. And there's really two ways to think about this. So the first way to think about it is, let's call this method 1. We have to take the 2,667 hiring managers, human resource professionals, and ask for ourselves, this seems to be about the United States of America. Would you say that's more than 10% of all hiring managers, human resource professionals in America?
No.
I would agree with you, probably not. There's a huge amount of companies, businesses, corporations in the United States of America, and they have these people in droves. Just about every company has several people who are hiring managers, human resource professionals. So in my opinion, just looking at the data, we can argue since we are, or let's make that look more official, we can say since 2,667 is not larger than 10% of all, and I will abbreviate this again, just say hiring managers. In USA, this condition is met. That's kind of similar to the problem where we're looking into a sample of, I think it was 270 children or something along those lines in Great Britain in 1974. 270 children in the entire country is nowhere near 10% of that population of kids in that country. The same idea here. Usually for these kind of problems, it's going to be pretty obvious that it's going to meet that condition or not. The only way it's not going to meet that condition is the population is some rarefied group of individuals. Maybe if the population is, say, an extremely rare genetic cancer, something along those lines. If we had this big of a sample for something that's a small population, now we're worried. Or maybe the population is everybody in just a rural town in Idaho. That would be a pretty problem too if we took a sample that large in a very small town. So the context should give you an indication one way or another. And for another way to think about it, method 2, this is how we did it in class. I think this is kind of a vague way to look into it based on the questions that I got about this in class. But if you take 10 times n, that's taking 10 times the sample size. That'll give us 26,670. All you have to argue with method 2 is that the size of the population is smaller than that number, 10 times the sample. If you can argue in that direction, the benefit of method 2 is it gives you a number to actually look at. Whereas over here, we didn't have any real number to compare. We just said 2,667 is not likely to be not larger than 10%. So take 10 times the number here, and the method 2 would be to argue, since this is smaller than the population size, of all hiring managers in USA, the condition is met. Well, any questions, folks, with either way to look at it, method one or method two? Okay, so let's look at that central limit theorem condition again. That's the 10% condition. Our sample should not exceed 10% of the population. And again, we did it this way in class. I'm not sure if that's the best way to go based off the kind of questions that came up on that. I think it's vague the more I think about it. So the trade-off of method two is 10 times n feels like you're doing something kind of weird, but it really is following this condition to the letter. You're taking n less than 0.10 times uppercase N, 10% of the population, multiplying both sides by 10 to get the 10n less than n. Well, last thing is the success failure condition. And that one's not too bad. For the central limit theorem to work, the number of successes in the sample have to exceed 10, and so do the number of failures. But that's not so bad because when part A, when you said hiring manager using social network sites to research job applicants is the successes, we already pretty much indicated the number of successes. There's 1,200 in this problem. So for the last part, we can say that there's 1,200, which absolutely is greater than or equal to 10 successes. And to get the number of failures, we'll go sample size n minus 1,200. The sample size is 2,667 minus 1,200, which is 1,467, which is definitely greater than or equal to 10 failures. So since we beat both of the benchmarks, we have more than 10 successes and 10 failures in the sample, we can say this condition is met. Or you might just say briefly, the sample size is large enough. And that does it on that one. So let's look through the conditions of the central limit theorem. Those conditions are important because the whole confidence interval procedure is directly based on that central limit theorem and the normal distribution we get out of there. Well, let's turn to a problem next. I think the next most logical problem is definitely a confidence interval one. So let's take a look at what we've got. Hopefully some definitely new problems. 37 is redoing that whole problem we just looked at as a confidence interval. We definitely haven't done that before. And 38 is probably done before, but never as a full-on confidence interval. So similar kind of problem still. I'll leave it up to the class. So up to you, either Bryce, Christian, or Abby. Should we try 37 or 38? Okay, let's give this one a try. It'll feel like more of a fresh problem with 38, so I think that's a good call. Do it. So this would be the last problem on exam 3. In doing this problem, you'd want to make sure on your note card you have some tools ready to go. So go to section 13.3. Let that thing load up. The thing that would want to get out of here is going to be definitely the formula for the confidence interval. Here it is, that's p hat plus or minus the standard error, and then the related formula for the standard error. But the next big thing is you don't have to calculate z star from scratch. You could if you want. It's an inverse norm problem. We did it for a weird one just to show how it goes. And notice it's kind of the same thing that we did in chapter 14. Only difference is it's the normal distribution and no degrees of freedom. But I'm not going to ask weird confidence levels on quizzes. We didn't on exams either. So when it says to construct a 90% confidence interval, you can just do a table lookup to get your z star directly. So let's work through the context and see just what's going on. National organization warns 30% of middle school students nationwide have been drunk. So this is a parameter value they gave us because it describes the population, all middle schoolers in the nation. But we're not concerned with that population specifically, we're just comparing to it. Concerned, a local health agency randomly and anonymously samples a simple random sample of 110 students, so that's our sample size, among the 1,212 middle school students in the city. Well, that's the population size. Sounds like a smaller town, so smaller than Idaho Falls. I think we have more middle school students in this city than that number. I wouldn't know exactly. That's actually something I wouldn't be completely certain on. Maybe it's about the size of Idaho Falls. But we have a sample size. This is our new population, all middle schoolers in this one city. Think Idaho Falls for something kind of a close example. 21 of them report having been drunk. That looks like that's 21 successes in this problem. So this would be 21 successes. So that's the context so far. It's kind of short and brief on this one. First thing we need to know to help us with our conclusion is, what is the parameter? It's categorical data, so we don't write to mu this time. Muscle memory might make us want to because that was the entirety of chapter 14. But P this time is going to be the population proportion of successes. Well, we have to say what a success is. We can say students reporting having been drunk. That's where we got the 21 successes. Population proportion of students that report having been drunk. You have to mention the population. You could say among all middle school students in this city. In fact, we know how many in this problem. There's 1,212. We can just abbreviate to among all middle school students in this city. So that's one way to write down the parameter. You might write it differently. You might say P is the population percentage instead of proportion of all middle schoolers in this city that have reported been drunk, having been drunk. That's just changing the order of successes in the population, and that would work out as well. But any questions or comments, folks, on getting down the parameter for this one? Okay, next, we're going to do the confidence interval.
That's where we just use that, or we have those little orange lines that said successes, like the plug-in fill.
This part right here.
No, back when we were doing the description. Describing population proportion of successes
Oh, yeah, that's a good point. I forgot about that.
and then population.
Yeah, that's exactly doing this part right here, essentially. So filling in the blanks on what is a success, what is a population. Other questions about that so far? It doesn't hurt to put that in the notes as well, just to be specific. This part right here is the success. Again, a success is not always a good thing. It's kind of jarring mentally sometimes. And when we said, oh, it really goes up to here, reporting having been drunk. And then when we said here, among all middle school students, this is the population. So yeah, that's a great way to think about these kind of problems. For the next part, we're just running right through the confidence interval procedure. Usually we had multiple parts on doing this. This one is written in as just one big part. So if it comes in as this kind of a question, this is what you'd want to do right away. Go, let me get some color coding going in here. P hat plus or minus the right Z star critical number multiplied by standard error P hat. So even if it's not broken down in parts A, B, C, and D, and so on, we can still kind of go in order. Just go left to right in the confidence interval as you see it. Step one, the first thing you'd want to do is just compute p hat right away. P hat is the number of successes, 21, divided by the sample size, 110. Let's throw that into the calculator. 21 over 110 gives us 0.19091. 0.19009. I'm rounding to the 5th decimal place, so I can round to the final answer to 4 decimal places. If you rounded this to 4 as well, that would have been okay on these. I'm not going to be super picky on the rounding, but just to get a slightly more accuracy until the last step, I'll go for 5 places on these results. Then step 2, we do the standard error of p hat calculation. Or no, let's keep this in order actually. Step 2, let's write in what z star is. Anyone see what z star should be in this problem?
1.645.
Yeah, absolutely. We match up the confidence that was described and grab that number there. 1.645 gives us that value. Now, going down the line, here's step 3 in this process. Compute standard error p hat. That one's a good formula to just look up to reference real fast before we throw it all together. It's going to be p hat 1 minus p hat divided by sample size n. Let me write that slightly more clean. It's easy to make a mistake when you put this in on your calculator. So if you put just this much on your paper, I would give some partial credit to this. But like we mentioned in class before, almost all the partial credit is if you put this down on paper. 0.19091, even if you round to 4 places, that'd be great. 1 minus 0.19091, let me try again, 0.19091 divided by sample size n, which is 110. So that right there is like an insurance policy. So everything that goes wrong in the calculator, it's not as big of a deal. But here's one way to do it in the calculator. Hit second square root, so you do the square root first. And you could type in this number, but this is a fantastic way to do it. You can up arrow, copy it in, saves you loads of time, and now you're even more accurate than these 5 decimal places. Do the parenthesis 1 minus part. So here's the parenthesis, 1 minus, then up arrow again, just copy it down in that kind of way. And it's not just about the speed, it's more about the accuracy. It's easy to make a mistake here. If the calculator is copying in like that, we've almost surely got the right thing. Now for this part, hit division by. Make sure that you're still inside the square root, that that bar continues to extend to the right. Type in 110. Let me know if you're getting anything different. I got on this one, 0.03747. How's that look to folks so far? Awesome, glad to hear that, 0.03747. So those are all 3 moving parts. Now we just plug them into those 3 spots. And hey, I think we're gonna finish this one in time, at least the part C portion. P hat is a 0.19091. We're adding and subtracting from the table lookup, 1.645. Then multiplying that whole value by standard error p hat, 0.03747. Let me put a quick border here to separate out these steps. Now we just jam all this into the calculator that we see here in the confidence interval, and we'll have p in the middle. Here we'll round this step to 4 decimal places. Let me clear this out. It's 0.190 91. Go minus 1.645 multiplied by 0.03747. And that's our lower bound. To 4 decimal places, I've got 0.1293. But recall what that means. It's fun to think about this as you're going through this because it's essentially your punchline at part C. This tells us close to 13% of the middle schoolers in this city have reported having been drunk. So that's a pretty high percentage. So let's hit up arrow again. If we flip this to a plus, hit enter again, we're at 25% roughly. As a proportion, it's 0.2525. But so far in this study, they have significant statistical evidence that in this one city, in this particular, the middle schoolers in this one city, they're below the national level. That's kind of interesting on this one. Both sides of the confidence interval are completely below the 30% mark on this data. So all we need now to do is give the practical interpretation to this interval. And this is kind of formulaic in a certain sense. We just mention the level of confidence. We might wonder if we were 99% confident, would that have changed our conclusion? It might have. We might have exceeded 30%, a higher level of confidence. This was at the low end for confidence. So that's kind of interesting in this problem. So we should always mention this. The interval looks nice, but at low confidence, we are 90% confident. It doesn't sound great, to be honest, when you think about it. It wouldn't have hurt them to be at least 95% confident. That. Then we come over here and say what P is, citing part A. The population proportion of students that report having been drunk among all middle school students in the city So that's P. That was kind of a longer parameter this time. And we just say is between 0.1293 and 0.2525. And if you like, you could call these 12.93%, 25.25%. You would just want to say percent in this spot right here if you change the units. That'd be a great way to interpret it as well. But we did it, folks. That's the whole process for the confidence interval.
There are part B.
There is. So these are the concept questions down below. And, since we're looking at them, it doesn't hurt to think about these. Anyone recall what would happen if the sample size decreased? Would we get a wider interval or a narrower interval at a smaller sample size? Turns out this one would be narrower. This one's weird because I think if you're thinking for narrower, you're thinking at a higher sample size. So if we bumped up the sample size from 110 to say 220, this becomes smaller and the interval gets narrower at a higher sample size. But what we're saying is decrease that value, make it smaller, like say 70 students. That makes this whole number itself get smaller. So if we make the sample size smaller, our interval will become wider. But does that make sense to folks thinking in those terms?
Yeah, I had it backwards.
And it's kind of weird because it's kind of posed in a backwards direction, right?
Okay.
Usually we say the sample size increases, giving the narrower, But the directions are reversed on both of these, so we'll say here. We'll miss the explanation because we're short on time, but we can say this would make it
It's gonna make the gap bigger.
exactly, so it's gonna make it a whole thing wider. Wider, and we can say, I guess briefly, since SE P hat root P hat 1 minus P hat over N gets bigger. You know, that's a tricky statement too. Why does the standard error get bigger? Let me see if I can bring it back. Here's the standard error computation right here. It was at the 0.03747. Now let's change it again. And let's literally decrease the sample size from 110 to, say, 70. My claim is the standard error gets bigger. If you make the denominator smaller, the whole thing gets bigger. And there it is. It's a little bit bigger at sample size 70. It's 0.04 rather than a 0.03. And one last thought. If the confidence level increases to 95%, do we have a wider interval or a narrower interval? Anyone recall what would happen on this one?
The confidence level increases.
Yeah. That means we're going from 1.645 to 1.96 right here.
So again, your confidence goes up, so you have a wider range of a bigger gap.
Exactly,
So
absolutely.
wider.
Yes, so if it increases at a lot of confidence, it's wider as well, absolutely.
You can go opposite of that, like you said, that one class. If you have 10% confidence of it being between 12% and 13%.
Yeah, exactly.
10% confident.
It's kind of useless at that point. Yeah, exactly. It's kind of like using p hat. That would be 0% confidence if you just give one number now.
Right.
And if you give just 10% confidence, it's like just barely bigger, barely smaller than that number. So we could say here briefly wider because Z star, we can see it in the chart above, is bigger. I mentioned these are not questions I'm going to ask on the third exam. I'm not going to turn in really tricky concept questions, but looking at them again for the review is just another way to think of the entire interval, all the moving parts. Well, any last questions or comments at all, folks, before we call it a night? Okay, well, thanks for making it in, folks. I appreciate the interactivity with the review. For the folks that see it later on the Zoom, I mean, that's helpful too. So let me know if any point anyone has any questions or comments while you're studying for the exam over the weekend. I'll be happy to help out. And again, if you get your quiz number 9 in as soon as possible, I'll make every effort to get that graded and turned into you before our exam 3 on Monday. But have a nice night, folks. Have a great weekend. Try not to work too hard if you can help it. And we're not going to be doing any too majorly different problems on the exam, just the 4 ones that we mentioned.
Perfect. All right, have a good weekend.
You too. Take care, folks.
Thanks for all your help.
You bet.